1.4 is the inverse of a relation. So what we're looking at is normally what we look when we discuss a function, we look at y is equal to fx, but what we want to do is see what happens when we invert it and we say x is equal to fy. So we're going to try one on the calculator and then do the comparison to see what happens when we change that. So in your calculator, if you enter y is equal to 2x plus 1, you'll get a graph that looks like that. Now, if we want to enter x is equal to 2y plus 1, you can't put that into your calculator because it has to be in y equals mode. So what you have to do then is you have to solve your equation for y. So first thing I would do is move my 1, so I'll have x minus 1 is equal to 2y, divide by 2. So I'm looking at x over 2 minus 1/2 equals y. Now you have a couple of different ways you can enter that into the calculator. You could put your x minus 1 all divided by 2, or you could punch it in the way I have it here. So if you did, and you have to use your brackets, move it down. So x divided by 2, bracket, minus 1 divided by 2, or 1/2 would work. So if I do my graph for that, you can see what has happened to it. It has, this is my original graph, is the y equals, when it's going, if I'm going to touch this, I don't think it's going to draw on here, but you can see where it's going there. And then my inverse, or my x over 2 minus 1/2, is this graph here. So it's kind of flipped it, if you want to think of it that way. So if I sketch my results here for, oh, I've got my first one on there. So for y is equal to 2x plus 1, I've got my y-intercept is there. I went up 1, 2 over 1. So there's what my graph looked like. For the graph of x is equal to 2y plus 1, I'm looking at 1/2 x minus 1/2. So my y-intercept, I'll do that one in red, was at negative 1/2. And then I was going, this is like saying 1/2 x, so I would go up 1 and over 1, 2. So it would be going there. So for my original graph, if I sketch the results, whoops, I should put these here. If I'm looking at my points, I had a point at 0, 1, and here it went to 0, negative 1/2. When I'm doing the flip, it's like the graph has been flipped over y is equal to x. So and it's hard to tell because my graph isn't exact on here. I'd have to actually plot my points. But y is equal to x is this graph here. So it's going through 0, 0, 1, 1, and so on. And because my line isn't straight. But what you would see is these are, if I had these exactly right, would be the exact same distance apart. So I would have my 1 point here. This red line should have been going through negative 1 and 1. I should have had one going through at 0 and 1. So that is there. That one is there. I should do these in red. So at 0 and 1. And then up here at 1. And 3, but no, it should be 3 and 1, sorry. and then, where am I? 1, 2, 3, 1. So it's pretty close. My line is pretty close to where it should be. On the original graph, those points were at 1 and -1. And then up here at 0 and 1. And then I had here at 3 and 1. So in the original graph, and I'll just write those out here, whoops. I had a point at 1 and 3. I had a point at 0 and 1. And then this third point here was at -1, -1. In my inverted graph, I had a point here at 1, 3. I had another point at 1, 0. And then I had my third point here was at -1, -1. So what happens to y is equal to fx when x and y are interchanged? Well, exactly that. X and y are interchanged. I just flip my x value and my y value. So I go from having xy to yx for my coordinates. And what's happening is it's flipping over this line, y is equal to x. So y is equal to x is just the straight line going through the origin, going 1, 1, 2, 2, 3, 3, and so on. So if I looked, this point here is exactly over 1, up 1, away, and on the inverted one, it's over right 1, down 1. So when left 1, up 1, this went right 1, down 1. So it's exactly the same difference way. So the reflection of it, if you want to think of it that way, is that xy line. So these functions are called inverses of each other. X is equal to fy. What happens to y is equal to fx when x and y are interchanged? So the inverse is found by interchanging the x and y coordinates. So that's just flipping them. Graphs are reflected in the line y is equal to x. When y is equal to f -1, that's called the inverse, is sometimes used to represent the equation of the inverse if it's a function. When the inverse is not a function, the domain may be restricted to the function portion of the inverse. So sometimes what you're going to find is you won't be able to do the inverse because you're going to have values that are not allowed. So like in the case of fractions, like rationals or radicals, where you can't do the negative of, or the square root of a negative value. The inverse of a function reverses the processes. So instead of graphing it xy, you'd graph it yx. Okay, so another example. Graph the function fx is equal to 2x minus 4. So if I take a look at this one, I'm saying my y-intercept is equal to 4, and my slope is equal to 2 over 1. So -4, sorry, that should be -4, 1, 2, 3, 4. And then I'm going up 1, 2 over 1. And just for the sake of having a straighter line, I'm going to do a couple more slopes. So 1, 2 over 1, 1, 2 over 1, and then I'm going to go the other way. Over 1, down 1, 2. Okay, so if I draw my line, try to make it straight. And this is where using a straight edge, doesn't have to be a ruler, but just a straight edge will help you. So it says, using this function, sketch the graph of x is equal to f y, or y is equal to the inverse function of x. So in my original graph, I was down here at -1, -6. Then I was at 0, -4. 1, -2. 2, 0. And 3, 2. So the inverse, if I do that in red then, means I should just interchange my values. So the inverse graph will be -6, -1, -4, 0, -2, 1, 0, 2, and 2, 3. So -6, -1 -4 and 0, -2, +1, 0 and 2, and then 2 and 3. So I connect those dots, and that's the way it looks. So if my line had been straight through here, you'd see my graphs would have crossed each other at that point. So that point there is, if they were straight, would be at 4, 4. So that's all it takes to inverting a linear function. When you're given the equation, you just pick out some coordinates, usually between 4 and 5 coordinates, so that you have enough to show the inverse, and then you graph it. So now it says find the equation of that inverse function. So to find the equation, I look for my x-intercept, or sorry, my y-intercept. So it was here. Actually, first I'm going to do it mathematically. So by interchanging, I had y is equal to 2x minus 4. So what I want to find out is what is it when I invert. So I have x minus 4 is equal to 2y, divide by 2. So I have x over 2 minus 2 is equal to y. Sorry, that should be a plus. So if I check on my graph, I've got a y-intercept at 2, and then I went over 1, or up 1 over 2. So that worked out. Okay, next example says, consider the function f x is equal to x plus 2. Graph the function. Is the inverse of f of x a function? So if I graph my function, this is just the graphing the parabola, or graphing a quadratic function. So I've got 2 is my p, or my h value, and 0. So I'm looking at my vertex is at -2, 0. My a value is equal to 1. So I'm just doing over 1, up 1, over 2, up 4. So it's just a normal graph. So at -2, 0, that's my intercept. And then I'm just doing over 1, up 1, over 2, up 4. And I can't do the 3 because I'll be off my graph, but you'll get the picture. So if I look at my original graph here, I had a point here at I just want to see where my, oh, there we go. Did I not go over 2? I only went over 1. This one. That's why it wasn't looking right. This one should have been over 2. Okay. Whoop. That's better. So my coordinates then, I had at -4, 4, -3 and 1, -2 and 0, and then I was at -1 and 1, and then 0 and 4. So that means my inverse should be at 4, -4. Sorry, that's just a 1. 1, -3, 0, -2, 1, -1, and then 4, 0. So when I graph the function, by looking at it, is my inverse going to be a function? Well, that means if I take a look, by definition, for a function, or for an expression to be a function, you can't have your domain or your x values repeating. So in this case, if I take a look, I have a repeat in my x, my 4 repeats and my 1 repeat. So I can tell right away that this is not going to be a function. Okay, so now let's graph this and see if we were right. So 4, negative 4. 1 and negative 3. 2 and 0, or negative 2, 0, negative 2, 1 and negative 1, and then 4 and 0. So that's the inverse. So I've taken and just sort of flipped it over. So it says, describe how the domain of fx could be restricted so that the inverse of f of x is a function. So what could we do so that this inverse works out to be a function? So basically, our domain restriction needs to be that our x values have to be either greater than or equal to negative 2, because once I hit negative 2, then that's where my repeats are starting, right? Here, when it's negative 2, that's when my repeats started, so I can either do everything above negative 2 or everything less than negative 2. So that would be my restrictions. Or that's how I could put restrictions on there so that my inverse could be a function. Okay, so find the inverse function for each of these functions. So mathematically, that means that I'm going to substitute in. So I have y is equal to 1 over x minus 2, so I have to invert it. X is equal to 1 over y minus 2, and now I solve. So I have, basically I'm cross multiplying. Y minus 2 is equal to 1 over x, so I just kind of switch places there. And I need to get my y by itself, so y is equal to 1 over x plus 2. Okay, and if you're confused at what I did here, basically, if I multiply this side by y minus 2 and this side by y minus 2, this will cancel, and I'm left with y minus 2 over x. So then I would have to divide by x and divide by x, and those two will cancel. Okay, so f of x is equal to x plus 2 all cubed plus 1. So first change it into the y equals. So now I'm going to invert, so x is equal to y plus 2 all cubed plus 1. So now I solve. So I'll subtract 1, so x minus 1 is equal to y plus 2 cubed. Now to get rid of the cubed, I have to cube root both sides. So I have cube root of x minus 1 is equal to y plus 2, because cubed and cube root will cancel. So I bring over my 2. So cube root of x minus 1 minus 2 is equal to y. Okay, there are going to be some questions where they give you the graph and they want you then to manipulate it by inverting it or applying something to the original function. So this didn't copy on here, so I'll just write it down. So if we're given that x is equal to fy, so basically we're just inverting our x and y coordinates. So the original function, which is on here, I had negative 5, 0. This was at negative 2 and 4. Down here was at 2 and negative 5. And then we went back up to 4 and 5. So the inverted, or the inverse, will be then at 0, negative 5, 4, negative 2, negative 5, 2, and 5, 4. So then you just draw those. So 0, negative 5, 4 and negative 2, negative 5 and 2, positive 2, yeah. And then the last one was at 5 and 4. 5 and 4. So that's the inverse of that one. So the B, if we do so in this one, we're applying two things. We're not doing the inverse because we're not flipping those x and y. But what this one wants us to do is to take our original coordinate and apply a negative to the x, and this 2 in front is being applied to the y. So these new ones will be, so negative 5 times negative, so this will be at 5, and negative 5 times 2y will be at negative 10. Did I do that right? Oh, sorry, it's a 0. So we're looking at the original. I looked at the... So 0 times 2 is 0. Negative 2, negative 4, so that's going to become a positive 2. And 4 times negative 2 is negative 8. Or 2 becomes negative 2, and negative 5 times 2 becomes negative 10. And then the last one, 4 becomes negative 4, 5 becomes 10. So that transformed function will look like 5, 0. So it's here. 2 and negative 8. So that's say down there. Then we have negative 2 and negative 10. So somewhere over here. And where's the other one? Oh, did I get a point wrong here? That should have been 2 and 3. Negative 2, oh, and 3. That's why. That should have been at 3. So this one should have been at 3. So my point will be off there a little bit, but it's not going to change the whole graph. But this will fix this one up. So this should have been at negative 2 and negative 6. I'm going to do an undo here. Okay, so this should have been a 3. So that'll be a 3 there. And this will be a 6. Okay. So 2 and negative 6 will be there. And now my negative 2 and negative 10 there. That makes more sense. Negative 2, negative 10, we'll say somewhere over there. That's a positive 6. Oh my goodness. So that one's not there at all. It's up here. Okay, so 2 and positive 6, not negative 6. Negative 2 and negative 10. So that's still going to be somewhere right there. And then the last one was at negative 4 and 10. Negative 4, positive 10. So it'll be like up here. So this graph goes more like this. No, that one's not there. Like that. Okay. And then the last one is y is equal to the function of x plus 2 minus 1. So what this means is, the way it's affecting this is to my x coordinate, sorry, that should be a minus 2. To my x-coordinate, I'm going to be adding 2 because I do the opposite. And to the y-coordinate, I'm adding 1. So negative 5, 0. Negative 5 plus 2, that becomes negative 3. 0 plus 1 becomes 1. Negative 2 plus 2 is 0. 3 plus 1 is 4. 2 plus 2 is 4. Negative 5 plus 1 is negative 4. And then 4 plus 2 is 6. And 5 plus 1 is 6. So my new graph will be at negative 3 and 1. 0 and 4. 4 and negative 4. Oh, 0 and 4, I put 0 and negative 4. 0 and 4, 4 and negative 4, and then 6 and 6. So it's moved it. So example 5 says if the point 2, negative 3 is on the graph of the function y is equal to fx, determine the new coordinates of the image of this point on the function x is equal to fy. So if 2, negative 3 was on y is equal to fx, then on the inverse, the new coordinate will be at negative 3 and 2. So it's just a matter of flipping those values. And the last page was just some additional questions. And I'm not going to do these ones. If you want to try them, and then you can come and show me, and I'll tell you if you did them right or wrong. But they're basically just the same thing as I did in those last examples. Okay, so your practice is on page 1. Oh, I didn't put the page number, sorry. Questions 1 to 15 and then number 7. When you're working on these ones here, though, you just have to see which is this being applied to. I'll do a couple of these ones on number 3 before I end. So this is changing your negative. So this is saying to your x-coordinate, or to your x-coordinate, we're going to apply a negative. So this one would be at 1 and 5. This one is applying to the y because it's affecting the function x. This point here is the same as the y is your fx. That's when you've inputted your values in. So this one would now be at negative 1 and negative 5. This means you're inverting it, so this would be at 5, negative 1.